Hi, I'm Neo. Welcome to the Mathemagicians. And today we will talk about the 9 laws of exponent. But first, let's start off with the basics. Yo.
Yes, Neo, and good day. Have you ever encountered one of these and this and wondered how do you solve that?
Well, we are here to help you out. Let us first start with x raised to 1. X raised to 1 would be the same as x times 1, or simply x. What would 3 raised to 1 equal to? Correct! It would be 3, because 3 times 1 will still be 3. Because anything raised to 1 will always be equal to number itself.
However, what if our example is x raised to 0? Then x raised to 0 will be equals to 1, because any number that is raised to the 0th power will be equal to 1. For example, 3 raised to 0 is equal to 1. And you call this as the zero exponent rule.
Now, if you understood the last example, it will be the same as x raised to 2, x raised to 3, because we know that the exponents are repeated multiplication to itself. But what if our exponent is negative? How could you multiply something together negative number of times? Let's discuss about negative exponent rule and we'll continue the rest of the rule. Blue.
For example, 4 to the power of negative 2. Since x, the negative exponent, means a repeated division, since the inverse of division is multiplication, x to the negative exponent is equal to 1 over x to the power of n. Now, back to the example. 4 to the power of negative 2 means 1 over 4 to the power of 2. Now, let's solve it. It will result to 1 over 16.
Next one is power rule. What if x to the power of m raised to the power of n is equal to x raised to the power of m times n? For example, what if 2 to the power of 3 raised to the power of 4? This means that 2 raised to the power of 3 times 4, which will result to 2 raised to the power of 12 is equals to 4096.
So the next one is one of my favorites, the product rule. X to the power of m times x to the power of n is equals to x to the power of n plus n. For example, 5 raised to 3 times 5 raised to 2. Since we have the same base of 5, we can proceed to add our exponents together. So it will be 5 raised to 3 plus 2. In result, we will have 5 raised to 5, which is equals to 3,125.
Next, the quotient rule. As the law says, if you have the same base of x to the power of m over x to the power of n, then it will be equal to x to the power of m minus n. For example, let's use the given we have in the last example. 5 to the power of 3 divided by 5 to the power of 2, which will be equal to 5 to the power of 3 minus 2, that is equal to 5 to the power of 1, where we can apply the 1 exponent rule. So that means the answer is 5.
That are the last 3 laws. Next one is the power of product. Through this, we will talk about the common exponent being distributed to different places. What if x times y raised to the power of m can be rewritten as x raised to the power of m times y raised to the power of m. For example, quantity of 5 times 6 to the power of 2. First, distribute the exponent 2 to our bases, which will be equal to 5 to the power of 2 times 6 to the power of 2, that is equal to 25, times 36 is equal to 900.
For our next law, it's a bit like the last example. However, the operation is different and it's called the power of fraction rule. In this rule, instead of times, we will use it in division. quantity of x over y to the power of m that can be rewritten as x to the power of m over y to the power of m. For example, 4 raised to the power of 2 over 7 raised to the power of 2. Since we distributed the exponent for both bases, 4 raised to x is 16 and 7 raised to 2 is equal to 49. And that will be equal to 16 over 49, or simplified as 0.3265.
And for our last law, which is fractional exponent rule, where x raised to m over n, that is equal to n root of x to the power of m. For example, 8 raised to 2/3 will be written as cube root of 8 squared, wherein 8 squared is equals to 64 and the cube root of 64 is equals to 4. The denominator will be the guide what root you are using, and the numerator are the exponent of the constant. Now that we are done, I hope you learned something from us.
Thank you for watching our today's episode of Laws of Exponent.
We are the Mathemagicians. See you again, guys. Bye.
Let's see.